In our previous video, we're able to determine the integrating factor we need in order for us to solve for the same linear equation in this video. So we're able to do that under using the concepts of p of x, which is 3x squared. This is p of x, and our f of x was this item here, x squared. Take note that our integrating factor that we had in our previous video is e to the power of x cubed. Okay? That will be used in further solving for this. That's why we separated the video in order for you to really appreciate the concept of integrating factor, and now it's used in solving the given equation. We can use this expression times y is equal to the integral of your integrating factor times f of x dx. So simply plug in here all the values. You will have e to the power of x cubed times y is equal to the integral of e to the power of x cubed times your f of x, which is x squared, times dx. So you will have this form, e to the power of x cubed y is equal to, you have here, we can start with x squared if you would like to, e to the power of x cubed dx. Okay? With looking into this one here, we could actually not use anymore the idea of integrating by parts, because if we are going to take this as our u, let u be e to the power of x cubed. Okay, our du is actually e to the power of x cubed times the derivative of the exponent, which is 3x squared, then dx. We already have x squared here, so we don't need to jump into the integrating by parts. What we need to do here is a product or additional factor of the constant 3. So let me copy the other side so that it would be continued here, equal to, so we are going to have e to the power of x cubed times 3x squared dx. But since we added here a factor of 3, to neutralize that change, we are going to multiply this by 1/3. That is because we don't want to change the entire expression. 1/3 times 3 is just equal to 1, so we're just simply multiplying the entire expression by 1. Now that we have completed this is now integrable. So you have here e to the power of x cubed, then this y here is equal to 1/3, and the integral of this entire expression, which is just e to the power of x cubed plus c. Okay, so plus c, we have the function, we have the arbitrary constant c. Okay, so the next step here is we would like to have a solution in terms of y is equal to something. So we'll be removing this expression. And how do we remove that expression? We can divide all sides or both sides by e to the power of x cubed to cancel that. Or other term is multiply both sides by e to the power of negative x cubed. So that when you multiply this e to the power of x cubed using the loss of exponents, you will have e to the power of 0. Of course, you still have y here, that's y in this case. But take note that you also need to do the same thing on the other side. Multiply e to the power of negative x cubed. This will also have the same effect as on the left-hand side. So you will have here only 1/3, and then plus c e to the power of negative x cubed. Now this is already the final answer. Of course not yet, because we will have to make this 1. So you have y is equal to 1/3 plus c e to the power of negative x cubed. This time, this is now the solution of our given linear equation. Again, we used here the idea of our integrating factor, and some of us might jump into the idea of integrating by parts, but it actually could be used or easier if we're just going to stick with this idea. We don't need to use integrating by parts in this concept. So that is all for this video. Thank you very much for watching.